So what we need to do today is to finish 4-4. Landon, you had asked me about the 1 extra credit problem. Did you still want me to make some time to go through that one? It was. It was. I was so glad. You have no idea. I mean, you have a small idea of how glad I was when you said that was extra credit, because I seriously thought I had gone nuts. Like, why did I assign that problem? What was I thinking? And then you said extra credit, and I went, oh, okay, yeah, that's what I was thinking. So I was grateful that that was extra credit. Okay. All right, so we're just going to work a little bit more on 4.4. We have 3 things that we have to get to. That's expanding, and combining logarithmic functions, the law of forgetting, and the change of base form. So, all right, so we're going to continue on here with 4.4, and we're going to work on expanding and combining. All right, so what we want to do is we want to use the laws of logarithms to expand each of these expressions. All right, so here's our first example. In our first example, we're going to take log base 3 of 8x, and we want to expand this using the laws of logarithms. If you will recall, there are 3 laws. The first law says if you have log base a of a times b, this is the same thing as log base a of a plus log base a of b. The second one says if you have log base a of a over b, this is the same as log base a of a minus log base a of b. The third law says if you have log base a of some positive value a to the power of c, that's the same as c times the log base a of that value a. So these are the 3 laws that we're going to use to expand this particular logarithm. Now 8x is 8 times x. Since I have a log base 3 of 8 times x, I can split this using the first law. Log base 3 of 8 plus log base 3 of x. I would point out that we're not doing this for a specific reason. We're doing it to practice a skill. All right? So there's not any other goal other than to expand this as much as we possibly can. That being said, can you rewrite 8 as a base and a power? What's another way that you could write 8 using a base and a power? That's exactly what I'm getting to, 2 cubed. So I could take log base 3 of 2 cubed plus log base 3 of x. And I wanted to do that because once I write this as 2 to the third, then I can use the third law to expand this further as 3 times log base 3 of 2 plus log base 3 of x. Mm-hmm. This is expanded. Yep. So now I have expanded this out as far as I can, and log base 3 of 8x would have the same answer as 3 times log base 3 of 2 plus log base 3 of x. Let's try a second example. Okay, we're going to expand a log base 5 of the expression x squared over yz cubed. All right, do you see how we have an a over a b? Because I have an x squared over a yz cubed, I'm going to first use the second law to split this into a log base 5 of x squared minus a log base 5 of yz to the third. Now, looking at this first log base 5 of x squared, I have an exponent on it, and I can use the third law to move that 2 out in front. So there's also you mean like an order of operation kind of thing? Not, there are a couple of things that we would do first. For example, I split the a over b first, right? Now that this one is separate, I can go ahead and put 2 log base 5 of x. Okay? I can't move this 3 up front because I haven't split these two yet. So now this is log base 5 a b. So I'm going to subtract, and this is going to be log base 5 of y plus log base 5 of z to the third. Now, because that's just a z to the third, now I can take that cube and put it in front of that log. And I'm also going to distribute that negative. So I'm going to have a minus 3 log base 5 of z. So I guess, Landon, I would say, is there an order? The only thing I would say is that this really has to be last. Yeah. But other than that, it's not a specific. In other words, I could have split these first and then gone back and put the 2s and 3s in front. It wouldn't have mattered. Right. Okay. We'll try one more expansion. Shoot, this guy's done. Okay, so what's the other example we've got in here? Ooh, maybe I should we try a really hard one? All right. We've got an ln of x times the square root of y over z. This one's a little bit fun. All right. But do you see how you do have an a times b here? So I could write this as ln x plus an ln of the square root of y over z. Square root is what power? Nope, square root. Y over z to the 1/2 power. Ln x plus 1/2 times the ln of y over z. Now I've got an a over b. So now I can use the second law to do an ln y minus an ln z. Oh, is it? Should be okay. Oh, is it? Is it? Okay. Okay. Yours is, Landon? Okay. Yeah, I just stopped sharing. So let's try. Oh, it looks like it kicked Landon out. Okay. All right, can you see the screen now? Okay. All right. So how are we doing? Can you see the answer? Okay. Any questions about this one? Yeah. Oftentimes they look. Yeah. Yeah. We're not trying to get to an answer. We're just like, we're not trying to get to a numerical answer. We're just trying to practice the skill, really. Okay. All right. So now we're going to do 3 examples where we use the laws of the logarithms to combine. All right, so we're going to work with the same 3 laws, and rather than expanding them, we actually want to combine them. So we're going to be using them in the opposite direction. So I'm going to give you an expanded one. Let's say 1/2 log base 2 of 5 minus 2 log base 2 of x. And we want to write this as a singular log. Now, in order for that to happen, we have to have the same base here. If you don't have the same base here, it's not going to work. Okay? So just like when you combine terms, you have to have the same variables. They have to be like terms. When you combine logarithms, it has to be like bases. So to work this out, if we have 1/2 log base 2 of 5, what can I do with that 1/2? Log base 2 of 5 to the 1/2 power, because I'm combining. The same thing with this 2. I'm going to switch it up and put it on the x squared. Now, I'm going to rewrite this as log base 2 square root of 5 minus log base 2 of x squared. These 2 are the same log, and I'm subtracting. So I can combine them to write it as log base 2. Since it's subtraction, it would be a over b. And I've taken an expanded logarithmic expression and combined it into a single log. Questions? Still good, Kristen? Okay. Turn the page. Thank you. Okay. Let's try one more. find these, I like to do it from left to right. So we've got an ln a plus b added to an ln a minus b. This would be an ln of a plus b times a minus b. Right? If you're adding them together, that's the same as multiplying them under the same log. Okay? Minus, and is it okay if I go to ln c squared there? Yeah? Okay. Now, I have all of this ln minus this ln. And that subtraction tells me I'm going to do what? So I'm going to have an a plus b, a minus b over c squared. Which, if I'm simplifying it, a plus b times a minus b is the difference of two squares. So I could do a squared minus b squared over c squared. Questions? Okay. Great. All right, then let's take a look at the law of forgetting. The law of forgetting is one of my favorite nonsensical math laws. It is an application of logarithms, and it is just that. It's an application. This is not anything that you have to like memorize. It's just something that I find interesting. All right, and the law of forgetting says this: if a task or a memory, right, is learned at a performance level P0. Then after a time interval of t, the performance level P the log of P has to equal the log of P sub 0 minus C times the log of T plus 1, where C depends upon the task and T is in months. So this is an awful lot of math, but think about something that you're skilled at. Maybe it's riding a bicycle, maybe it's driving, maybe it's your mathematics, right? This law of forgetting gives you a level of mastery. And then when you don't do it for a number of months, it can predict how much of that mastery you've lost or how much you've maintained, right? On a very basic level, for me, I haven't ridden a bicycle in probably more than 25 years. So if I get on a bicycle right now, I'm not going to have the skill that I had the last time I was on it, right? If you have children, you see this with your kids over summer vacation. We lose some of what we've learned. We have to fall back a little bit. I'm a little bit worried about driving. I haven't driven in a couple of weeks. So where's my driving skill going to be when I go back to it? The law of forgetting gives us a way to measure that. All right. So what do we want to do? We want to A, solve for P. Okay. And then we're going to do some stuff. Okay. So we want to solve this for P. Log of P is equal to log of P sub 0 minus C log of T plus 1. Okay. If we're going to solve for P, it is already on a side by itself, with the exception of the log. So I need to combine this side so that I get to one log function. So looking at this, the first thing I'm going to do is put this C up as an exponent. Now I see I have a log of some value A minus a log of some value B, and that minus tells me that I can do the log of P sub 0 over T plus 1 to the C power. These logs are the same base. What base are these logs? So I can do this a couple of ways. If the log of P is equal to the log of P0 over T plus 1C, doesn't that mean that P has to equal P0 over T plus 1 to the C? Right? If log x is the same as log y, then x and y have to be the same. If you don't like that, the other thing you could do is put them both as exponents on the base 10. In that case, the logs would cancel. But either way will work. Now I have solved for P. Part B says, if your score on a history test was 90, what score should you expect on a similar test after 2 months. Assume C is equal to 0.2. So what would your retention be here after 2 months? And again, now we just got to plug and chug. Our P would equal P sub 0, which is 90, over T plus 1. 2 months was our T, so 2 plus 1, to the power of C, which is 0.2. So I'm going to have 90, not 91, 90 divided by 3, the 0.2 power. And I get a 72.25, about. Still passing. For our courses at a 70%. All right, questions for me? We're still good? Okay. All right, then the last thing from 4.4, and it is kind of a big thing, is the change of base formula. All right. We use the change of base formula because sometimes we're asked to make calculations with bases not on our calculator. Or to combine or expand logs that do not have the same base. Whoops. In those cases, the change of base formula is useful. Okay. So we're going to pretend that we have some log base A of x. But you need log with a different base of that same x. Then you can do the following. For log base b of x, we're going to let that be some value y. Then in exponential form, we know b to the y has to equal some value x. Base to the exponent has to equal to the result. Now, I can take, because these two are equal, I can take the natural log of both sides, or I could take the log base x of both sides. Why would I use the ln or just a regular common log? Why would I use it? What do an ln and a common log have in common? ln and log base 10 are the only logs on a calculator. So most often we use the ln or the log because they are the only two on the calculator to use. All right, so if I do that, then I can pull the y out front. ln b is equal to ln x. And now I can divide both sides by ln b. And I get ln x over ln b. This is our formula. No, because you're taking the natural log. The logs don't cancel like that. It's the natural log of x over the natural log of b. All right, so this gives us the change of base formula, which says if you have a log base b of x, this is the same as that log with a base a of x over the log with a base a of b. So, log base 4 of 20. I can't find that. There's nothing on my calculator that allows me to do a log base 4. I have a log base 10 and I have a natural log. I don't have a log base 4. So I'm going to use the change of base formula to rewrite this as, I could use any base I wanted. I could use a log base 7 if I wanted. But log base 7 isn't going to be helpful because it's not on my calculator. The only two on my calculator are a log base 10, the common log, or the natural log, ln. So you choose whichever one you prefer. But this will look like the ln of my x value, 20, divided by the ln of the base. On my calculator, I'm going to do ln 20, and I'm going to divide it by the ln of 4. And I get about 2.161. Again, I could have done log base 10 of 20 over log base 10 of 4. I should get the same number, log 20 divided by log 4. It doesn't matter which one you use, just try to be consistent. Good? Okay. We try another one like that? If I have to calculate the log base 7 of 2.61. I don't have log base 7 on my calculator, so I would use the change of base formula, which says I could do the natural log of 2.61 and divide it by the natural log of 7. Oops. Watch your parentheses when you plug these in, by the way. So if I did ln 2.61 and I just hit divided by, that's going to cause an issue. I've got to make sure to hit the parentheses. All right. Great. Okay, questions for me? Kristen, anything? You're good? Okay. You're doing good today, though. All right.